Hello everyone and welcome to a new video. In this video we are going to solve exercises that's related to chapter 13.1 oscillation and periodic motion. Okay, a boy on a swing completes 10 cycles, so the number of cycles is 10. N is equal 10. This is the number of cycles. In 12 seconds, the time of the cycles is 12 seconds. What is the frequency? Knowing that, in order to find the frequency, we need to construct the following triangle F, N, T, because by definition, the frequency is the number of cycles per unit of time. So in order to find the frequency, we need to hide the frequency. Frequency is equal N over time, the number of cycles divided by the time of this cycles, so 12, 10 over 12. Plug this in the calculator and we will get the answer, and the answer is 0.83. So the frequency is equal 0.83. What is the unit here? We know, since we are using here the SI unit, and the only unit that we have here is the second, because the number of oscillations or cycles is unitless. So the unit should be 1 per second, or we can use second minus 1, but we commonly used hertz because second minus 1 is equal to hertz. So no need to use 1 over s, neither second minus 1, we will use hertz. Therefore, the SI unit of frequency, it's hertz. Okay, neutron stars were originally mistaken to be possible extraterrestrial life because of their precise frequency. If one emits radiation with a period, this is the period in seconds, so we know T is equal 8.5 seconds. What is this frequency? There is another relation that help us to find the frequency. It's given by F is equal 1 over T. Whenever we have the period, we can easily find the frequency by applying this formula. Therefore, 1 over 8.5, plug it in the calculator and we will get the answer. 1 over 8.5 is equal to 0.11. And therefore, the frequency in this case is 0.11. Also, since we are using here SI unit, the answer will be in SI unit, and we know the SI unit of frequency is hertz. Standard alternating current in the United States is 60 hertz. So the frequency is 60 hertz. At this frequency, how many complete cycles, we need the number of cycles, current make in 4 seconds. So we need to find what is this number of cycles in a given period of time, which is 4 seconds. Recall that the frequency is the number of cycles per unit of time. Let's construct the triangle of frequency. Frequency, number of cycles per unit of time. We need to find the number of cycles, so we need to hide it from the triangle and rewrite the formula as F times T. So the frequency times the time of cycles. The frequency is 60 and the time of cycles is 4. Plug it in the calculator, we will find the number of cycles, and the number of cycles is 240. Do we need to use here any unit? No, it's unitless. The number of cycles is unitless. Okay. Jose watched the sea and noticed 42 waves crest pass by in 1 minute. So the number of waves, or the number of cycles, or the number of crests is N is equal 42 in 1 minute. T is equal 1 minute. What is the frequency and the period of this wave? So we need first of all find the frequency, then the period. Okay, let's find the frequency first. We know by definition that the frequency is the number of cycles per unit of time. Therefore, we can construct this triangle in order to find the frequency, number of cycles per unit of time. So we need to find the frequency. Therefore, we need to hide f, number of cycles per unit of time. The number of cycles is 42 and the unit of time is 1. But in this time, if we keep the same units here, where t in minutes, we will not get frequency in SI unit. So it's necessary to convert minutes into seconds. How can we do that? We know that in order to convert from minute to second, we need to multiply by 60. Therefore, 1 minute is equivalent to 60 seconds. So all that we need here is to multiply by 60. 1 minute times 60 in order to get the answer in SI unit. Now plug this number in the calculator, divide 42 by 60, and the answer is 0.7. This is the frequency in SI unit. Now let's try to find the period. As we said before, there's a relation between period and the frequency, where always we can use 1 over f to find the period, and if we have the period and they ask us to find the frequency, we can apply this formula. So this formula connects or links between period and the frequency. So since we have the frequency here, we can use this formula in order to find the period. So t is equal 1 over f, 1 over 0.7. Let's plug it in the calculator, 0.7, and the answer is 1.42. Therefore, the period is 1.42. What is the unit used here? Since in the denominator is SI unit, the answer also should be in SI unit, and we know that the SI unit of period is second. Okay, radio station broadcast at 91.5 megahertz. Convert this frequency to hertz and write your answer in standard form. So this is not the SI unit, the megahertz. We can convert it to hertz by apply the following formula. From megahertz to hertz, we need to multiply by 10 to the power 6. And if we have kilohertz to hertz, we need to multiply by 10 to the power 3. But we will use the first one since the question is related to kilohertz or megahertz, sorry. Therefore, 91.5, this is the frequency, just multiply it by 10 to the power 6 and we will get the answer. And the answer in the standard form, 0.6 times 10 to the power 6 is equal to 916.1235 hertz. Okay. A radio station broadcast at frequency of 127.7 megahertz. What is the period of the radio waves from this station? So the frequency is 102.7 megahertz, and we want to find the period of this frequency or the broadcast. Remember that the frequency is the number of cycles per unit of time. The period is the time needed to complete one cycle or one oscillation. There is a relation between them. The relation is given by this formula. F is equal 1 over t and t is equal 1 over f. Whenever we have t, we can find frequency and vice versa. Therefore, we can use this relation in order to find the period of the broadcast. So 1 over f is equal 1 over 102.7, but remember that this is not the SI unit of the frequency. The SI unit of frequency should be in hertz. Therefore, we need to convert it in order to get the SI unit or the answer in SI unit, which means we need to find the answer in second. How can we do that? Just convert megahertz into hertz. So all that we need to do is to multiply this number in the denominator, which is basically the frequency, by 10 to the power 6. Plug it in the calculator. 102.7 times 10 to the power 6. And the answer should be 9.73 times 10 to the power minus 9. What is the unit? The unit is seconds. A boy in a swing completes 10 cycles. So this is the number of frequency or number of cycles. It's 10. I think this is already, we have solved it before. So let's go to the next question. A wave with a frequency of 14 hertz. So the frequency is 14. Has a wavelength of 3 meter. Wavelength of 3 meter. At what speed will this wave travel? So we need to find the speed. We know that the wavelength is the distance between two consecutive points. And the speed is given by this relation, v is equal lambda times f, the wavelength times the frequency. Let's construct the triangle of this relation. V lambda f, we need to find the speed in this case. Speed is equal lambda f, where lambda is the wavelength, f is the frequency. So 3 times 14, plug it in the calculator, and we will get the answer. And the answer is 42. What is the unit used here? Since we are dealing here with SI unit, 3 meter is the SI unit of wavelength, hertz is the SI unit of frequency, therefore also the output or the answer should be in SI unit, and the SI unit of speed is meter per second. The speed of a wave in 65 meter per second. So the speed is 65 meter per second. If the wavelength of the wave is 0.8 meter, so the wavelength is 0.8 meter, what is the frequency? We need to find the frequency. Let's construct once again the speed wave frequency triangle. By hiding the frequency, we can find it. Frequency is equal speed over wavelength. The speed is 65, the wavelength is 0.8. Plug it in the calculator and we will get the answer. And the answer in this case is 81.25. What is the unit used here? We know that the speed is in meter per second, and meters per second is the SI unit of speed. For the wavelength, also it's given in SI unit, which is meter. Since the whole fraction in SI unit, the answer should be in SI unit, and the SI unit of frequency is hertz. Okay, a wave has a frequency 46 hertz and a wavelength 1.7 meters. What is the speed? So the frequency is equal 46 hertz and the wavelength is equal 1.7 meter. We need to find the speed. Let's construct once again the triangle. Speed, lambda, frequency, knowing that lambda is the distance between two identical consecutive points. Therefore, in order to find the speed, we need to multiply the lambda times the frequency. Lambda is 1.7, frequency is 46, and the answer should be, after plugging in the calculator, 78 0.2 meter per second. Why it's in meter per second? Because both frequency and lambda in SI unit. Therefore, the answer should be also in SI unit. A wave has a wavelength 125 meter, is moving with a speed 20 meter per second. What is the frequency? Let's construct it again. Speed, lambda frequency. We will hide frequency. The speed over lambda. The speed is 125. Lambda is 20. Plug it in the calculator. 125 over 20. And the answer is 6.25. What is the unit used here? The unit should be SI unit because lambda in SI unit, which is meter, speed in SI unit, meter per second. Therefore, the answer should be in SI unit, and we know that the SI unit of frequency is hertz. A wave has a frequency 900 hertz and wavelength 200 meter. At what speed? So we need to find the speed. Let's construct the triangle. Speed, lambda frequency. And the question asks us to find the speed. Speed is equal lambda f, lambda 200, frequency 900. Plug it in the calculator. 200 times 900, and the answer should be equal to 180,000. What is the unit used here? Also SI unit, because all the input values here are in SI unit. Therefore, also the answer should be an SI unit. And the SI unit of speed is meter per second. The radio waves travels at speed of light, 300 million meter per second. So the speed is 3 times 10 to the power 8 meter per second. A broadcast radio waves at a frequency of, this is the value of the frequency, what is the wavelength? So we need to find the wavelength. Speed lambda f, so lambda is equal speed of frequency, which is equal, the speed is 3 times 10 to the power 8, the frequency is 1017 times 10 to the power 5, and the answer is 2.94. What is the unit of lambda? We know that in the input we have all the values in SI unit, therefore the output should be in SI unit, and the SI unit of lambda is, or the wavelength is, meter. Thank you for watching, and see you with the next video soon.